So I'm going to go ahead and see if I can actually find you guys, because for some reason I wanted to go live later, and yeah, it's not doing that. So I'm going to try to find a way to get you guys on here. So please know that I am there. Let's see here. I'm live. And yeah, let's see if I can get you guys on here, this live stream. I hope so, and I will send it to everyone. I will go to Google Classroom, so I'll be right back, you guys. Please don't hesitate. Hold on, Rocky. And I don't know. I tell you, I'm YouTube, not live channel, maybe now live. Okay, I'll try this. Hopefully I get something. I don't know. Cancel, add. Oy vey. The wonders of modern communication, huh? That's what works. So I did get a question from one of your classmates, and the question was, what's the difference between a particle of a compound and a particle of an element? Well, the smallest particle of a compound is called a molecule, and it usually has two or more elements that are chemically combined. And the particle of an element is called an atom, and they all have the same number of protons. Here? Nope, just me. So anyway, let me see what else I can do with live chat. Participants? No, just me. Let's see if I'm pushing all these buttons right here. Let's see what I have here. Oh, back to the classroom. And yay, it hasn't. Done that. And I'll do this. And I'll do that. Come on. Come on. Come on. Come on. Come on. Yay. Yay. Add link. Come on. 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 Anyway, I just hope I reach a lot of you guys, because you guys are so special that I like to spend my time helping you. So the due date for this is tonight. I know you guys are going to go crazy, but the test is tomorrow, and I want to make sure that you're able to study. I know I worked with some people today, and basically what I want you to know is I've put all of the quizzes so that you guys are capable of using them throughout. And hold on, my dog is, of course, whining, because that's what he does. Rocky, that's open, because that's the way things are, right? And you've got a ton of tabs open, and it's not letting me choose a topic, because, of course, it would be so much easier if I could. Everything is going so slow, but that's the way love is, and that's the way things go, right? Anyway, Rocky, that's enough. That is enough. Anyway, I hope you guys had a great snow day, because I know I did. It was very resting and relaxing. One more day tacked on to the end of the school year. But right now, this time of year, who really cares? It's beautiful. It's near Christmas. Okay, so are there any questions? 12 people, 13. Yay, welcome. Let's see who was all here. I hope I have a lot of participants. Well, I'm the only one, I think. But that's okay. Let's see. Hi, Harry. It's good to see you. The link in the classroom didn't work, but sorry about that, guys. I had it set up ahead of time, so I put a new link in. Okay, so you're going to find a new link. And Lily, welcome. So sorry I got the congratulations, you got here. Yay. I'm so glad you're here. Hi, Darcy. Back to the classroom. The old link is there, and so is the new link. I just put in the new link like 5 minutes ago. So any questions? Anything? So I don't see any questions yet, but I love to help you guys, and you know that's my number one thing. I love. One of the other questions I got was, what's the difference between compression and contraction? So compression is when outside pressure is applied and you have a decrease in volume, whereas contraction is when the temperature change, that is, it gets colder, causes a decrease in volume of an object. And hello, Gasper Medved. Any others? Questions? So those are the two questions I got previously from somebody's email. Hi, Addison. Why did we change the coefficient when balancing the equation rather than the subscript? Well, remember, the subscript tells you how many atoms there are. If I wanted to balance that equation of H2 plus O2, and I only change the subscript on O, so then it would be balanced in the new of molecules of water that are created. So it is. I hope that answered your question, Addison. Oh, you mean the parentheses? So, Ned, I'm trying to work out the parentheses that you're talking about. Are you talking about that one example where they had a parentheses around NO3 and then a subscript 2? Well, that was telling you how many of those nitrate ions bind with copper and don't worry about that. You will not get anything like that when it comes to an equation. What you will get something instead is being able to, from the number of molecules that we give you, be able to write a chemical formula, okay? So please don't worry about the parentheses, all right? That was actually something that you would probably get at the high school level. So you guys figured it out. But what it does is it sets it apart. For instance, on the back of a sheet of paper, I'm going to draw what I think that you're talking about, okay? So you had NO3, NO3, something like this. Now, this is going to look backwards to you, I think, if I find it. Yes, it does. And I apologize, but you know what I'm talking about, right? And then you had the parentheses around it, like 2. See the bottom, like 2? Now imagine that's written right. I have not developed my writing backwards gene, so sorry, I didn't write backwards. But what that means is this. Occasionally you'll get this, but you will not get this on the test. You see this subscript here? That means that you multiply this 2 by the 3, and then this 2 by this, but you don't create N2O6. What you have is instead 2 groups of NO3. So then it would look like this. Here's one group of NO3, and here's another group. That's what it means. And let's see if I can have it there. You see the 2 groups of NO3, the 2 groups of NO3, chemical reaction. That's the big fish. Do you understand the difference between what happens to particles when there is a chemical reaction? Do they change? No, they just break apart from whatever they're connected to. So like in the case of salt, let's use salt. Let's say you had a chemical reaction and you had 2 particles, NaCl. Okay, let me draw Na, let me draw Cl. See? And of course it's backwards, all right? So you have NaCl, and they have a chemical reaction. These 2 will move apart from each other. So the chemical reaction is that the salt moves apart. So then here it is after the chemical reaction has occurred. You notice there's the, oh, by the way, I made it larger because so you could see it. It doesn't get bigger, okay? Let's see. Oh, I've got some more questions. Let's see, I have the same question. The writing shows up the right way for us. Cool. For me, it shows up the wrong way. No, not so much. The quizzes is fairly representative. Do also check out the atoms, because I did leave off atoms and periodic table. So just check those out too. What is the format of the test? Multiple choice. There are a couple of questions that are I have to grade on my own, open response. There are some fill-ins. So your usual test questions. How many? Enough to get through in a period? I would say there's 37 points possible. So somewhere around there. The chemical reaction between hydrochloric acid and sodium bicarbonate. So when baking soda, which has the chemical formula, this is the chemical formula of baking soda, NaHCO3 plus HCl yields sodium chloride plus water plus CO2, which is a gas, and you'll see my arrow going up. That's the chemical reaction. Can you see that at the top? There you go. That's the chemical reaction for baking soda plus hydrochloric acid gives you sodium chloride plus water plus CO2 gas. Okay? Hopefully that was helpful. And Darcy, I think, I wouldn't worry about it. Just take your time, go over the quizzes, okay? And I've put out every quiz I could possibly think of. And for those of you that are here, 7-8, I opened it up so you can see the questions and the answers. So, check those out, okay? Let's see, Addison, chemical reactions are occurs when you have the elements break apart from the other elements in a chemical formula and they're rearranged to form new substances. Why does it happen? Usually something they don't form water all the time, but something has to act as a catalyst that causes this reaction to occur. And usually it's the catalyst that causes the reaction to occur. Okay, so, Max, you had the same question, and that's the answer, Max. You have these two elements that come together, bing, and form a different substance that's totally not like the previous substance. Think of sodium, nasty stuff. Think of chlorine, it'll kill you. And yet, when the two chemically combine, you get table salt, sodium chloride. You use it all the time on your food. Up is gas, precipitate is down. You are correct, Harry. Harold. Oh, two Harrys in a row, Harry and Harry. You're right next to each other. Hi, Harrys. And let's see. Any other questions? All right. I'm happy that you guys in a survey chemical. Could you go over the? I don't know. Teddy. Wait a minute, Jed. Can you just write the question and then I can do it? I think what you're talking about was the one where the temperatures were the same. And then you put it outside and the temperature went down more than the other temperature of the other water. They both start at 85 degrees Celsius. What you have to realize, you have to ask yourself, did you use the same material to put the hot water in? That could be the difference why it's different temperatures. And Harry, my other Harry, hi. I got two Harrys. I'm a lucky person. Yes, exact same volume, but one container causes a loss of energy more than the other. That's what it's talking about. What is the formula to figure out the final temperature? Oh, you remember? You add the two temperatures together, if it's 2, and divide by 2. If you have 5 different temperatures, you add the 5 together and divide by 5. And that's how you figure out what the final temperature will be. You take the high and the low, and yeah. Is that helpful? Is this the one where you write yes or no for the chemical reaction? Oh, is that the one? Oh, okay. So why don't you, what I don't have is that, believe it or not, I very seldom print out one for me. I always keep it on the computer. However, I will let you know that when it comes to a chemical reaction, the one that isn't a chemical reaction on the top half, yes or no, it is not when you add the temperature increases and then you get bubbling and then the gas. That's called boiling water, okay? So basically, from what I walked around with, most of you got it right. If you have one, let me know. Brian, what is the density formula? Density equals mass divided by volume. You got it, Harry Lefevre. Darcy, you got it too. Harry, are you a model student? Excuse me, Addison, you're talking to Miss Moss, not each other. And yes, he is a model student. Thank you very much. I have your back, Harry. Um, His mass over volume. You remembered, Esther. Awesome. Awesome. You guys got it. So, yes, practice those density things. I put the quizzes on density. I don't know if you saw that early, but the quizzes on density is open to you. I opened up as many as quizzes as I could. You say that word quizzes as often as you can. By the way, I please excuse my dog. Whenever I'm on the phone or talking to someone else, he gets jealous. And so therefore, he's whining. I don't understand what your question is, Zayden. So I'm really taking this serious because I'm giving up valuable time with my family to do this. So Zayden, what is your question? Okay. What is your question? Zayden and Kennedy. This isn't time for this because ultimately I want to keep it serious. So Zayden, what's your question that you have about science? You know what, Zayden? Always forgiven. I always forgive because life is too short to carry a bone. Tell me about it. So, Rocky, you can stop barking now. You're embarrassing yourself. Anyway, so any questions? I'm here for you. Any question you have, this is the time to ask. By the way, I really like this. I think next test I'll do this too. You know what, Kennedy, you know density. So as soon as you write in there, I would get a scrap piece of paper and write the density formula down so you don't have to try to remember it if the question comes up. Okay. So Zayden, glue and water would be a mixture, okay, because there would be no chemical reaction. Harry, I will go pick up Sir Barks-a-Lot. That's his nickname. His real name is Rocky, but I will pick him up. Right now he's a fluffernutter because I let his hair grow during the winter. And so he's like a little huge fluffernutter. The quizzes is in, go on quizzes and then log in using your school Google account. And then I've given it to you. So all of them are there. The solute is a substance that gets dissolved in the classroom early tomorrow, as always. And anybody, when you arrive, oh no, my connection's unstable. Come on, connection. Oh my goodness. Is it better? Are you guys still there? Okay. You guys, you can come to my classroom tomorrow. I'll be there. You know, I get to school early, but as soon as you get down, come on down. I'll be there. You can just ask me any questions, whatever you want, okay? At the particle level during a chemical reaction, remember, particles are elements, are molecules. So what you do have is, let's say, this is one element, and this is a connection. This is a molecule, and then chemical reactions occur. Boom, breaks apart, and combines with another element. Now, this, of course, this pen would have had to have been in the reactant phase. It can't just show up in product. So, unfortunately, I only have two hands, and therefore I can only do it, that way. But keep in mind, when you have a chemical reaction, you do have that occurring. Esther, are you in the blue classroom? After this, I'm going to check and then making sure that you've lined up in a blue classroom. If not, I will give you join codes, okay? So after this particular chat, I will make sure that you're going to have the join codes if you're not signed in the blue classroom on quizzes, all right? Oh, no, you're not in blue. Are you in blue or red? Whatever class you're in, I'm going to make sure you're in, okay? During a chemical reaction, do particles lose or gain kinetic energy? We don't even worry about kinetic energy when we're talking about chemical reactions. When we're talking about increasing heat or decreasing heat, gaining energy or losing energy, that's when we're talking about it. So don't worry about kinetic energy for chemical reactions. Okay, change. Then you look at kinetic energy. So Esther, I'll make sure you do that. Hey Brady, welcome. What makes up all the substance? Oh, atoms. You can't trust atoms. They make up everything. Remember that joke, okay? That'll get you through everything. Remember, atoms make up everything. Will there be any questions on calories? No, don't worry about calories. And atoms, you can't trust atoms. They make up everything. Remember, atoms make up elements. Elements make up compounds. What is the easiest way to see if a chemical reaction? Actually, you don't have to worry about making it up. It's when you have a chemical equation literally describes what has already occurred. So it's kind of like a way that we've put it together to the earth. Okay, thanks. Are we inside the earth? Okay, Mia, I don't know who you are. So we have to study vocab because it's not about the words, it's like you understanding what's going on. To me, that's most important. So what you do is you notice that we've talked the vocabulary the whole time. We didn't just memorize some words and then never see it again. You've actually lived. How much longer do you guys want to stay on? Oh, and Harry, let me get my dog for you in case you are, so that because radiation. Yeah, convection currents occur in liquids and in gases. Look at my lava lamp. It's convection current. It gets hot, becomes less dense, particles move apart, and it rises. And then it gets cold, particles get closer together, and the lava falls. So throughout the quiz, the test, look at my lava lamp for convection. Conduction is when things are touching. We need to move faster, bumping up against the next particle, which should cause it to move faster, so on and so forth. That's conduction. And the way the sun shines is... Come here. Come here, Mr. Rockefeller. They want to see you. Oh, goodness. All right, here's Rocky. All right, he's a fluffernutter. He's got a lot of hair right now because it's winter, but when he gets his hair cut, he's so much better. And he won't look at you. Come on, look at the kids. All right. Oh, I know. You're sitting on the chair. You've never sat on this chair before. All right, there you go. Now, that'll let him stop whining for at least 5 seconds. Okay. Conduction is when elements are touching. You are correct, Kennedy. Oh, endothermic and exothermic action. And what's left behind is cool. And then exothermic is when it felt hot to the touch. So remember chemical reaction, okay? Yes, hot, yes. Endothermic, exo hot, endo cold. You got the Model Student Award. You're taking over for Harry. Okay, so Harry, are you still there? And Esther, I haven't forgotten about you if you're still on, all right? So, any others? Oh no, I know. Addison's, Harry, you're still here, and I just want to let you know that Addison's been answering questions. Oh, you know what? I will get you in there after this is over, okay? Esther, don't worry. I will send you via email all of the join codes. There's going to be one for each of them. All right? This is when you measure in a graduated cylinder, okay, water, and that's really key, you guys. Remember, you guys lost points on that. So here's the graduated cylinder. I'm drawing this on a piece of paper. And this is the graduated cylinder. Here's the water. This is the downward curve. This is the meniscus. That's what you measure by, you guys. Remember, don't measure up here. So if you want to find the volume of a liquid, always measure by the meniscus. Good question, Kennedy. And it's spelled with the MEN, and the rest you got. Okay, thank you. Can you quickly go over the difference in melting and dissolving and solute, solvent, and solution? Well, melting is dissolving. Instead of that particle becoming a liquid, it's still a solid, but the water molecules hit up against the molecules of the salt, and I'm using salt as an example, breaking away just one molecule at a time. Okay, so it's not dissolved. It hasn't melted and gone into the liquid phase. It's just little tiny solid particles that you can't see. Okay, that's the difference between the two. And a solute is what dissolves in a liquid. The solvent is what the liquid is, in this case, water. And the solubility, its ability to dissolve. Okay, and the solution is what's created when the solute has dissolved in the solvent. A solution, you can't tell the difference between the solvent and the solute. It looks like one substance, not two. Okay, the test is tomorrow. It will not be delayed because on Thursday you're still going to Bodeborg, and Friday you have all those other tests. Okay. Did I answer all the questions? Any others? It's quiet. My dog is now by his dog dish wanting to eat again. Oy vey. He loves his dog dish. Yes. In fact, he's standing there going, feed me. Jesus. Or is it me? I don't know. It's a three-way tie? Or what happens at the particle level during a chemical reaction? Well, Kennedy, you tell me. Remember, particles break apart. And this is at the particle level. Literally, one element with the other element, they move apart, and then they rearrange on the others, and rearrange to form new particles. Yes. Somebody write down what the density of water is. Anybody? Someone? Anyone? Anyone? Density of water is one. Oh, I may as well give you the answer, which I always do. And yes, Angus, you are Mr. Davidson's model student. All right. The density of water is 1 gram per milliliter. Okay, or 1 gram per cubic centimeter. Remember, don't forget the label. We try to fool you with the label. Moving up there. Oh, Harry's got 1 milliliter per cc. Wrong, Harry. It's 1 gram per cubic centimeter. Correct, Harry. You got that wrong again. Oh, yeah. You putting down the fake ones? Okay. Evaporation, Kira, is a physical change. Remember, all the phase changes are physical. All phase changes are physical. It says it's not, oh, good. My correct is good. Yeah. Remember, all phase changes are physical. Remember, water is water, H2O, whether it's a solid, liquid, or a gas. All right. Keep that in mind. If you can't remember and we ask you about any other chemical, always in the back of your mind go, oh, it's always the chemical formula for water is always H2O, whether it's a solid, liquid, or a gas. And that's the same for any substance. Okay? No, the test is only going to be counted as 2. So just relax. All right? It's only going to be weighted 2, not 5. That would kill somebody's grade. Oh, no. Hey, Teddy. Oh, there, Jet. Is the test covering everything we learned this year? Yes, it will. That's why all the quizzes are open. And you know what? You guys are going to do fine. I know you will. I don't think it's a midterm, but it might be. I don't think we're having a midterm this year because we've already done it. And so when we come back in January, we're starting with my favorite, planetary science. I got to admit, everything I think is my favorite. You might have to do one little tiny equation. Oh, as far as balancing equation, that was the question that someone asked. Are we going to be able to extend time if we need more than one class? That you have to ask Angus. You might have to ask Mr. Davidson. Sorry about that. I moved it. I was looking at my hair. Vain. I should sing that song about myself. You're so vain. But anyway, any other questions? Let's see. By the way, I will be there, of course, my usual time, and I will have the room set up so that anybody that comes and study, I would say work in pairs, study together, because the more you study together, the better you'll do. Yeah, that's right. Remember, kinetic energy is measuring your temperature. In fact, the definition of temperature is average kinetic energy. So if you increase the kinetic energy, what's going to happen to the temperature? The temperature is going to increase. Decrease kinetic energy, the temperature decreases. Okay? And by decreasing the kinetic energy, it allows the particles to get closer together and they move slower. Remember, what state would it be in when there's no thank you, model student Harry Lefevre, for answering Jed's question. And model student Addison, are you still here? And model student Harry C., are you still here? And model student Esther. And Mr. Davidson's. So what's neat about this is that it will have a stream on one side and it'll have the video. And what I can do is I will publish this so that you can see this anytime. And it'll have the questions on one side and my answers on the other. Feel free to, share this with someone, and yeah, I'm just checking out my hair. Okay. Anyway, I'm so vain. What is the difference between melting and dissolving? Well, melting is a change in kinetic energy that causes a phase to a liquid or a gas. Is that helpful? Oh, Danny Betts has an application to be a model student. We'll see, Daniel. We'll see. And Darcy, the same. So, anyway, I appreciate this levity and humor. I enjoy the humor. Oh, and Darcy, you work so hard. So, of course, you're a model student along with my other model students. And Harry wants to have it all to himself. Harry C. wants it all to himself. Meanwhile, my dog is still, doing his dog thing. So anyway, it's 7:42. I've been on for 42 minutes. This live stream is 39 minutes long. So anyway, it's been a pleasure. If you think of any questions after this, email me and I will respond by email. Okay? And it allows you to be in your own home and do it other subjects and come in and listen in. And there's a video record of it. So you guys, it's been a pleasure. And I will see you all tomorrow. Spread the word that it is on tomorrow. And, get some rest. Remember, I've got my brain food. Ooh, I got to go out and buy brain food because I'm down on brain food. And it's kind of slick out there. So I've got to get brain food. Anyway, it's tomorrow's. I'll get some brain food on the way in the morning. You know where to get it. And if you just happen to walk by the brain food container and get a piece of brain food, oh well, it's yours to eat. You guys have a good one. Good night. And it's been a pleasure. Bye. How do you... It's ending slow.